Hello SolidWorks Power users, this is Alin Vargat with the preliminary results of the SolidWorks Power User Challenge number 33. Warning, this video is not going to be pretty. I am recording my analysis as I'm doing it. So if you want to skip forward, to fast forward to the end to see who won, feel free to do that. Thank you very much for those of you who submitted your result. I have only one person that I wasn't able to download his files. I'm hoping that I'm gonna get it, so that's why this is a preliminary set of results. What we needed to do, if you guys remember, simply based on the pictures that I posted, we are supposed to recreate a vase, doing reverse engineering. And you have a section view through it, right? You have the front view, you have the top view, and there are a couple of very important clues in all these views. Like if you're looking from the top, looks like there is a smooth surface on the inside, right? If you're looking on the outside, seems to be not that smooth. And probably the most important picture, the one that would provide the best clue on how to do this the easiest way, is the bottom picture. So probably notice here you have a polygon, which makes things so much easier, right? So if you're looking at the shape that we have on the bottom, it's a polygon, and this polygon seems to be swept. So if you pick up any of these points, it's being swept on something that looks like a variable helix. So that should have provided the idea about how to do it the easiest way possible. In a way, I'm glad that none of the contestants picked the easy way, chose the easy way. So they did things that were quite complex, quite interesting. There are many ways to judge this, right? Many criteria, and the main one I'm going to say is the accuracy. So let's jump directly to the files that I received. This is the original vase. We're going to go through the steps on how to build it in a moment. And I put together an assembly containing all the entries that I received before the cut date. There is one extra file that I received from Michael Fernando after, so we can take a look at that too. These are the ones that I was able to download. Okay, and notice here the overall shapes seem to be done pretty nicely. We have this uncoiling aspect of the vase, like you take this thing and kind of stretch it out. Works nice. All the contestants were able to do that. Now let's see who did it the best way. And I'm gonna start with the entries from chronologically, because one of the criteria is who posts the entry first gets a special consideration. So starting from here, right at the top, the first one who submitted a model was Stefan. So let's take a look at Stefan's file. I'm just gonna hide all the other ones, and let's take a look what we're seeing here. So again, hide. Okay. The gray one is my original file. The yellow one is Stefan's, and I'm gonna say this is pretty bang on. Look how nice this has been done. Even the fact that on the top this is pointy, this is spectacular. I don't care about the fact that I put some fillets here. This is what we wanted to see. Pointy, smooth on the inside, perfect match. The only thing that's a little bit off, and allow me to hide my vase. Actually, not even that. Everything is peach. I was under the impression that this was not a flat, but it is. So great job there. I think this is very, very close. Now let's take a look at how Stefan did this. So first of all, great job here preparing the file, right? So he started with an axis. He knows there's going to be some revolving going on. Then he added the pictures. So this is a great set of skills for any users of of SolidWorks. Notice he placed the pictures that I posted on the various planes that are relevant to us. He also named them. So this is excellent. This is perfect. Okay, perfect. Then the next thing, he found out that there are certain areas in on this picture that can be used for defining planes. So notice here a reference sketch that, if I'm looking from the front, is going through this intersection points on the original part. Very interesting approach. And then he created the planes based on that sketch, right, at different levels. And the first thing he did was an actual loft. So he created sketches. And one thing that's interesting, he used the polygon tool, I think. Let me edit the sketch. Let's see if that's true. Is this a polygon? I think it is. So he identified the fact that this is a polygon. So I'm going to take it back, saying that nobody noticed that. Actually, Stefan noticed that this is a polygon. Great job. One cool thing about polygons, ladies and gentlemen, it's one of the most versatile tools in SolidWorks because you can change the number of sides quite easily, and the relations are being preserved. So this is spectacular. Nice found there. Very interesting that he chose the loft approach. Okay, so if I'm hiding all these sketches, and that's another thing that I like to do, sometimes create kind of selection sets for this to hide and show easily, but I think we can do that also. No, we cannot do it with a folder, right? But imagine if he would have had this as a selection set. So let's add here, let's call it ref pictures. And you want to hide and show them, you simply simply select, right click on the empty space, show. Then again, select all of them, right click on the empty space and click hide. So something to consider for the future. So he created this as a loft, right? He created all the sketches at various levels based on the picture that I sent. So very, very accurate. Then he identified the fact that this is symmetrical, so it can be mirrored on both sides, right? And there you go. We were able to create that uncoiling effect. And then he split the top section in order to clean it up. And actually, that's interesting. Let's take a look at what he did here. So did a little bit of he used the intersect tool for that. So very, very interesting to achieve the end result. Combined the two. And then he used a revolve cut to make the vase hollow. Stefan, I'm absolutely thrilled with your solution. Like, I was thinking that everybody's gonna go the sweep way. You chose the loft, and I see why that makes sense from the reverse engineering point of view. So great job here. And also, this is extremely, extremely close to the original model. So great job there. Excellent. Let's take a look at the next entry. So the next entry was submitted by a mysterious user called 3DS. And you can see again the shape is pretty close to the original shape of the vase. If I'm hiding my file, you can see that we have polygonal surfaces at the bottom, so we know that. There is one thing here that hasn't been done, which is getting this pointy aspect at the top, right? So if I'm showing again the original file, you probably notice that it kind of finishes in pointy areas. Let's take a look at how this looks like from the side. So everything seems to match acceptably well. Not as perfect as Stefan's, but pretty close. Let's take a look at the model, how this was created. So again, kudos for documenting the feature tree. Great job there. Let's take a look. how this was done. So I'm going to press Ctrl T to flatten the feature manager tree, and let's start from the beginning. Looks like we have a few sketches that are defining. Let's see actually what they're defining. So make sure sketches are visible. Sorry. Yeah. Okay. So what do we have? We have the pictures inserted in SolidWorks. Great job there. And then we actually have the helix, which matches the shape pretty nice. Next, we have a revolve body for the overall shape, again matching everything, very nice. And then I think this is let's see, is this an intersection curve? Oh no, sorry, another revolution on the inside, and then an extrusion on the outside. Okay, so let's show all the bodies right now. You guys can see the transition. One thing that I would recommend is making these pictures transparent, so you can make the background, the white background, transparent. It's making everybody's life a little bit easier. And then, ooh, this is so interesting. That is so interesting. There was a split line over there, and that was in order to create this helicoidal surface. Okay. Good. Let's hide these surface bodies and also hide these sketches just to see what we have so far. So the surface that we are working with, let's take a look at this, is that trimmed helix. Okay, so if I'm showing you all these guys, let's pick up these ones. You can see the result. So it's actually starting to look pretty interesting, and I believe it's also the original shape, right? Wow, what an interesting approach. So you are getting the edges first, and then a couple more surfaces here, and the result, then we have a loft using this as guide curves. And the interesting thing, this is still a surface, a bit of trimming done, and we got an interesting shape, which actually it's a solid body, right? So you can see this is the solid body. Let's hide the surface bodies right now. This is spectacular. So also I'm going to hide all the sketches and everything. This is unbelievable. Look at that. What's next? Okay, working on the top. Now, let's get all the solid bodies visible. Started to look as something that we can recognize. Okay. And then kind of doing the top and the bottom, mirroring, deleting some of the faces. I think this is a cut with surface command, if I'm not mistaken. Yep. So he just found a section that can be repeated. Right? I think we have also another pattern. So let's show again this result. So it's again about identifying the symmetry. You identify what the symmetry is and finishing it up. So pretty interesting approach, very interesting approach. I just wished that the top would be pointy. I think that would have helped. And I'm afraid I might have thrown you in the wrong direction by filleting those edges, so you probably thought that these are chamfers. Okay, so great job here, a lot of work, for sure. So I'm not gonna save it, I'm simply gonna reload your file. Okay, the next one, the next entry came from Michael Fernando. One thing that I'm gonna say in this case is that Michael did a great job getting the uncoiling effect. Also, if you're looking from one side, you have a pretty good matching, but at the top, for some reasons, I don't know why, this deviates quite a lot from the original shape. The other thing is, let's open the file and let's take a look at it. I think the thickness is off. Everything is much thicker. Probably would look very nice 3D printed, but this is a little bit off. One thing that's interesting is that the file feature manager is much compact, much more compact than before. Right, so he started with a helix, picking it up from the original file set. Got the surface revolve. So if I'm looking at this, this is what you have so far. A surface sweep. So let's show the surface bodies for the time being. As you can see how the two surfaces are intersecting, which allows us to find the intersection curve between those two surfaces, which also allows Michael to create the first solid sweep. So if I'm hiding this, you can see he got the first solid sweep. Made it a little bit longer, and that in order to allow for intersection between the two of them, running the mirroring, intersect, so he got the pointy end this way, very interesting approach, and then circular pattern, okay, boss, extrude, revolve, and this one I believe he did it in order to get the bottom, and pretty much the job is done. So great job there. Again, a little bit off, but very impressed with how small is your feature manager tree. How short is your feature manager tree? He came, I hope I pronounced your name correctly, also came with an interesting approach here. So look at the pointy ends. One thing that hasn't been done here is completing the inside cut. So I don't have a smooth cut here. Everything kind of it's polygonal, or not really polygonal, but faceted. Let's take a look at the result of how this was done. So this was the shortest feature manager. The overall shape was done pretty nicely. So started with a revolve. And interestingly enough, this is a surface body. And one thing that's interesting also, he kept both the top and the bottom. And then a swept surface. So far we are following the surface modeling course, which allows us all this sweeping. If I'm flattening the feature manager, notice it allowed us to find this intersection curve. So that's the next thing that he did here. He found the intersection curve. And from the pictures, he found the beginning and the end of what can be used for a loft. So you can see this loft created, patterned, and also he identified very correctly the fact that this is going to be mirrored. One thing that he didn't have time to do is to complete the bottom, complete the top, complete the inside cut. So very interesting. If I'm looking at the end result, pretty close, a little bit off, but pretty close. I have one more entry which unfortunately I cannot download other than as a 3ds. This is as an XML. This is coming from Zeynep. So let's see if I can insert his file in here as an XML. Yeah, I tried that, and unfortunately at this point doesn't work. So I'm not sure. Maybe he has it right also, but we'll wait for him to upload the SolidWorks file. Now let's take a look at how the original vase was created. One thing that is important is the fact that this is a polygon. So let's start again from the beginning. Same thing, like all the users started with a shape, the overall shape, created a helix. This is a variable helix, so that allows me to work on the uncoiling effect, making it more pronounced or less pronounced by simply adjusting these parameters. Swept surface, based on that helix, and then finding the intersection curve between these two. Once you have the intersection curve, and this is the cool thing, we can simply use the polygon. Let me hide the surface bodies. So I have this octagon at the bottom that is going on that intersection curve, right? So you can see the result, simply having a polygon that kind of spins around as it moves on the path. So easy solution. Mirroring it, again, all the contestants notice that this is mirrored. And then I combine the two, so now I have one file only. Created a surface for cutting. You might say, why didn't you run directly a cut and not a surface and then surface cut? And again, it's about making sure that the result is as robust as possible. And then I got these flat faces here. So the solution was running the delete face with delete and patch option to get the sharps. Okay. Everything else after this is just a matter of capping the bottom. I use planes for that. So I just define a plane and then running intersect to cap the bottom of this vase, and then just cosmetic fillets. Okay. So based on what I have seen so far, I'm gonna say that Stefan is the winner of SolidWorks Power User Challenge number 33, and he will get the Power User certificate. I also want to thank all the participants. Very interesting solutions. But if we were to pick a winner from, I'm gonna say the accuracy is the main criterion that we can separate the solutions, and Stefan got the closest, and also he was the first one with the entry. So congratulations, Stefan. You will get the certificate. And Zeynep, please send me the file. If your solution is better than Stefan, you are also gonna get the certificate. Thank you very much. I learned a lot from your solutions. See you at the next Power User Challenge.